Let's solve question number 3. Show that the curve y equals a over x and y equals b over x squared always intersect at exactly one point P and find the coordinates of that point. So since y equals a over x and y equals b over x squared, we need to find the intersecting point so that you can make an equation as a over x equals b over x squared. And since we don't like variable in the denominator, multiply by x-axis, x-axis. Then you can write x times a equals b. Therefore, you can find the value of x as b over a. And then if you substitute this value into here, then y equals a over b over a, which is a divided by b over a, which is a times a over b, means that a square over b. Therefore, it intersects exactly only one point because it has only one solution of this equation. Then the coordinate is b over a, which is the value of x, and a square over b, which is value of y. Let's see the question B. The origin and P are opposite vertices of a rectangle with sides parallel to the coordinate axis. Show that the area of this rectangle is independent of B. Okay. Let's see the origin. And P, this is the P, but we don't know the exact point, but let's just assume B over A here, and then A squared B is here. This one is P. They are opposite vertices of a rectangle with sides parallel to coordinate axis. It means that x-axis and y-axis. So the rectangle should look like this way, right? Show that the area of rectangle is independent of B. Then the length of this rectangle is B over A. The width of this rectangle is A squared over B. Therefore, the area of this rectangle is B over A length multiplied by width. Then you can cancel this one, you can cancel this one, which is A. So since area of this rectangle is A, only dependent of A, it means that independent of B, because it's not related to B, only A is the area of this rectangle. Understand? Question number 4, find the condition of M in terms of A and C so that the curve y equals A over C is a tangent to y equals mx plus C. We need to find the condition of M in terms of A and C. Okay, firstly, let's draw the graph of y equals x, A over x. So since we don't know whether A is positive or negative, just let's assume that A is positive. Then y equals mx plus c is a straight line graph with gradient m and y-intercept c. Then the gradient c is here. Okay, students, I'm very sorry. There was a phone call. So, and then y equals mx plus c is a straight line graph. So you can see if the straight line graph can be drawn in this way, then it's a tangent line, right? So we need to find the condition of m in terms of a and c to be a tangent line to this curve, right? So y equals mx plus c and y equals a over x. You can make an equation like a over x equals mx plus c, because if this line is tangent to this curve, it means that they have only one intersection point. If this graph can be drawn in this way, there is no intersection point. If this graph is drawn in this way and then they have two intersection points, understand? So to become a tangent line, it means that they have one intersection point. This is the key part to solve this question. Then make a simultaneous equation and then combine them together by eliminating y. Multiply by x each side, because we don't like variable in the denominator. It's gonna be a equals mx squared plus cx. So you can find a quadratic equation from them, and then since it's one intersection point means one root, one repeated root, you need to find the discriminant b squared minus 4ac as 0. So the coefficient of x squared, which normally we use as a, is m. Coefficient of x, which is b, normally we use it. And then constant is c. Then c squared minus, it's a bit confusing because we have a and c and b and in different way, right? C squared minus 4m n minus a equals 0. Therefore, c squared plus 4ma equals 0. 4ma equals minus c squared. So m equals minus c squared over 4a is the condition to become the straight line as a tangent of this curve. The next question, function fx is a cubic polynomial. So show graphically that curve y equals 1 over x can intersect this curve in 0, 1, 2, 3, or 4 places. Okay, it's difficult, right? But since they ask you to show graphically, it means that draw a graph, right? Let's draw the graph y equals 1 over x first. And then let's start to find the cubic polynomial with no intersection point, which is this way, y equals negative x cubed. Do you understand? Okay, then one intersection point. One intersection point, if I were you, I'm going to, to move this graph down and then make one intersection point. Sorry. Slightly to make one intersection point and move this one. Since this 1 over x, this graph cannot go over this y-axis, and the cubic graph, it needs to go through the y-axis in this case, so that if it has one intersection point, then we can make it that they cannot meet again. Two intersection point is easy. Draw this graph in this way, right? Draw this graph in this way. Then 1 and 2. Then 3 intersection point, how we can make it? We can draw the cubic graph 1, 2, and tangent, and then 3. We can make 4 intersection point as 1, here 2, 3, and 4. But actually this question is very difficult. So you may try to draw many types of graph of cubic polynomials so that you can come up with those ideas how to draw, but it's very difficult.